Cool. And I will share my screen. Okay. Can you all see my screen? Cool.
Yes.
Great, thank you. And so I guess if we remember how like Jupyter Notebook works and how we can open up Jupyter Notebooks, when you open it up, it looks something like this, where you have all of your files and you can click through to different folders or click on specific Python notebooks. One thing I wanted to mention, which I don't think I mentioned at the 2020 school, this layout here is for Jupyter Notebook. There's something called Jupyter Lab, and you can switch between the two by going up into this, into the URL area. And remember, we're using our web browser, but we're not actually online. So this is all local to my computer. I can delete the word tree and type lab. And if I hit enter, then it opens up what's called Jupyter Lab. And it's the same thing. It has all of the same content. It's just in a different, like visualized differently. So I can still open notebooks. I can click Python 3 and it'll open up a notebook for me. And I still have the same thing where I still have all these cells that you can cut and copy and paste and all that. And then I have my list of folders and everything over here. So that can be really nice if you want to be able to see all these. You can also do, oops, I'll say new notebook. Oh, that didn't work. Oh, I can't open another notebook. That's bizarre. Okay. I wonder if it's because I've had this running all day. Let's close a few of these. So this is another feature of Lab, of Jupyter Lab while we're here. So this tab up here on the upper left, oh, I should do this so it's bigger, has all the folders. If I click this one that looks like a stop button, then I can actually stop running notebooks. And sometimes if you have too many notebooks running, your computer will get overloaded. So here I can, let's see, I will shut down that, and I will shut down that, and I will shut down that. So we'll see if that helps. See if I'm able to start a notebook. Yep. So now I can open another notebook. And so one thing that I really like about this, hello, welcome, Parakabina.
Yes, thank you.
Saying that correctly. Yes, welcome. I just started.
Yes, thank you.
We're kind of diving in, so please feel free to ask questions throughout. It's an informal tutorial, so I'd love to hear questions.
Okay, thanks.
So one thing I really like about this Jupyter Lab compared to Jupyter Notebook is you can put Jupyter Notebooks side by side. So now I have these two notebooks side by side, and sometimes I'm doing very similar work with a few differences, and then I can just kind of copy and paste text between the two. So that's pretty nice. Yeah, so this is Lab, and at any time you can just go back up here and delete Lab and type tree again, and you get back to what we had before, the Jupyter Notebook. So I thought I'd show that because a lot of places are using Jupyter Lab these days. And the idea is that like Jupyter Lab is like a lab notebook where you can organize all of your notebooks. So yeah, they're very much related. Nicholas, I think you just joined. Welcome. Hopefully, I'm kind of diving in. We'll see if I lose you, please stop me and ask questions. Happy to get questions throughout. Oh, I'm having so many people join. Okay, so so we remember that we can either go up to this upper right corner here, type new Python 3 if we want to start a new notebook, or we can click on an already existing one. So, and I already have this Python lab open for us. So this is the Python lab that I wrote for the 2020 school. and it can be found on the Slack channel, Python Help. And it can also be, is also found on the website if you click on Python programming on the COESSING website. If you need links to any of these things, let me know. I can paste them in the chat. Oh yeah, I realized I can't seem to see the chat. Let me pull up the chat just in case anyone's writing in there. Yesterday, I didn't check the chat, and at the end, I had all these things that I hadn't seen the whole time. So yes, and also if you are not on the Slack group and you'd like to be, let me know. Just send me your email through the chat here, and I can add you to that Slack space. It hasn't been used very much at the moment, but it's a great place. I'm on Slack like pretty much every day, all year, so you can ask questions at any time, and I should respond within a day or two. So okay, back to this Python lab. So hopefully before you go through this on your own, so the idea of these Jupyter notebooks is that you can walk yourself through, that I've written out enough here that you can kind of walk yourself through it. So we'll go through it together at the moment. Yeah, you can go back and hopefully understand all of the steps based on what I've written. Before you go through this one, I recommend going through this other one, which I have posted, which is the Introductory Jupyter walkthrough, and it gets you used to using Jupyter Notebook. And it also kind of introduces you to a few useful libraries like Pandas, CartoPy, which is for plotting, and a few others. And actually, before we go any further, I'll bring up the COESSING website. So this is the website for the summer school, or I guess the mini school, which we're in now. If you click on the 2020 plus 2021, first of all, you can see there are links, the link here to materials and videos from the 2021 school. So if I click on that, you can see here are all the videos. I just put these up today of various panels with the slides. And I have here the video of my Python tutorial from yesterday. And I'm recording this one as well, so I'll post that. So you can see resources there. Just go back to this page. Now, if I scroll down and click on Python programming here, it takes you to this page. This has a video with, I didn't make it, but it's a link to a YouTube video that shows you how to install Anaconda, which is how you can install Python and Jupyter Notebook and several other packages on your local computer. And so this kind of guides you through it, and this is for Windows machines. Google Colab is another platform option. It basically runs on Google Cloud, which is pretty cool. And you can do small computations on Google Colab for free. So basically, instead of downloading Python and Jupyter to your own computer, you can run it on Google. So I won't be going into that today, but happy to answer questions about that later if you have them. And then here are the walkthroughs that I was talking about. Here are some video tutorials that I made as well. And then here are a bunch of all the different labs that use Python at this school. So anyway, lots of resources there that you can find. Okay. So I think a few people came in since I last. Yeah, Mabel, hello. And oh, Abiodun, you're back. Great
Hello.
to have you back.
Yeah, I'm back.
Yay!
Yeah, I was able to join.
Yay, fabulous. So for all the people who just joined, this is an informal seminar, so interrupt at any time and please ask questions. I'm not going to go through some of the basics right now. Hopefully you can guide yourself through those if you need it in the videos that I just mentioned. But I'll go through all of these and hopefully it's helpful to see me like how I write the code. So, but yeah, questions are encouraged. Okay. So we are going to start going through this lab. So I guess, yeah, Jupyter notebooks have different cells. So you can see here, if I'm clicking on different cells, it has them highlighted. And you have this cell here, for instance, is a markdown cell, which you can see up here. It says markdown. This cell here is code. So you can go up here and now it says code. And so this is where I can write the Python code. So to start, we write down this %matplotlib space inline. This is necessary so that we can see plots in line with our text. So if we didn't have this, then we wouldn't be able to see plots in our notebook. And I actually am not sure, but I think potentially in newer versions of Jupyter, you won't have to do this, but I think you still have to for now. So I just pretty much start every notebook with that because I usually want to make some kind of plot. Now we're going to import the libraries that we're going to use. So the first one is Pandas. And each time you start a notebook, you have to import that library. But once it's imported in a library, you don't have to import it again unless you close it and reopen it. So this time we're going to import Pandas. And so you do that by writing import space Pandas. And then as PD is basically a nickname for Pandas. So instead of having to write Pandas down whenever I want to use that library, I'm just going to write PD. And then when I use, as we can see in this next cell, I have PD dot. And then this dot is kind of like calling upon the library Pandas. And then I'm using this function called read CSV in this case. And I know that that belongs to the Pandas library. Similarly, we'll import matplotlib.pyplot as PLT, and this is for plotting. And we'll import NumPy, which is like numerical Python, as NP. And so these are some standard libraries that you will almost always come across. Maybe not each one every time, but I very frequently use these. Okay, and so I have to run this cell. And so I can either go up to this top here and write and click run. And now I run it. Or I can type shift. If I hold down the shift key and then type return or enter, that's another way of running a cell. So here we are reading in the CSV data file, which happens to be called this. And because I live in Canberra, Australia, you all get to read in some temperature data from Canberra, Australia. So I'm assigning this data set to be called T for temperature. So I'll shift return. And notice here, like in this cell that I haven't evaluated yet, there's nothing there. Whereas these two cells that I've evaluated have numbers in them. That's how I know that I've evaluated them. So now I have data loaded as T, and we might want to look at what T looks like. So we can do that by doing T dot. So again, that's accessing within T, this data set, dot head, and that prints out the first 5 rows of our data. So if I do that, it looks like this. You also can, I'll just add a cell here. You can just type T, and if I evaluate that cell, then you also get a visualization of the data. The T.head is kind of nice because here you have the first 5, but then you also have the last 5, and you see these dot dot dots. That means that there are a lot more rows that aren't being shown, and that's because there are 4,400 rows, and it didn't want to print 4,400. Oh, thanks, Mabel. It's a bit small. Is that better? Yeah, let me know if not. Cool. Hopefully everyone can see this okay. So yeah, that's why I often use T-head, but you can use T as well. So now we can look at this data. So what I've written here is that T is called a data frame. A data frame is just a name basically for what you see here. So it's a name for a data set that's stored in like list form. So I don't know what kind of data that you all work with, but often you have data that's in list form. So like here, if you have temperature, so here it's temperature every day. So you have your day, month, and year. So you have your date, and then you have a temperature, which in this case is Nan, but a few of them are not. And you have a few other things here as well, some of which might be useful. Yeah, so when you have this kind of list data like this, Pandas is really useful, and this is what is called a data frame. And what's nice about a data frame is that you can have different types of data. So if you want to, if you have data that comes in as numbers, so like temperature, you have temperature of 10.5 or something, but then you want to connect that to maybe a word, maybe it's the location that the temperature was taken at. You can do that. So you can have numbers and you can have words kind of connected in the same data frame, which is really quite nice. So it keeps everything really organized. Okay, so let's go here. And this t.dtypes is going to print out the type of data that we have in each column. So that will make more sense when I evaluate it. So here we can see on the left is the name of each column. So that's product code. And we can see that product code is the first column of our data frame. And so on. Here's the Bureau of Meteorology station number, and so on. So for each of the columns, the data has a specific type. So in this case, we have an object. That's, yeah, a bit, I won't really go into what an object is at this point, but it's one form of a type of data. But ones that you'll more often see are int, so that stands for integer, and you have float, which is a decimal number. So we can see here that we have a few different types of data in each column. So I think it's very useful to use the Pandas date time functionality. So often when we're taking data, or at least in my experience, taking earth or environmental science kind of data, we have a date associated with it, sometimes a date and a time. And so Pandas has a native way to handle that, and it's called date time. And so here we see PD, so remember that's the Pandas library. So we're accessing the Pandas library and we're using this function called to_datetime. And that means I want to convert a few of these columns, in this case, the columns that are titled year, month, and day. We can see those here, year, month, and day. And we want to recast all of these into what's called a date time. And so let's see what happens when we do that. And in this case, I'm saying T with these square brackets of date time means that I'm actually creating a new column. So we should see a new column pop up after this. So I evaluate that, and I'll evaluate the next one. And you look over here on the far right, and sure enough, there's a column called date time, and it has the dates that are over here, but here they're consolidated into one. And if we look at the format of date time by evaluating this dtypes cell again, we can see that this date time column here is in fact a date time type. And the NS stands for nanoseconds. And so Pandas can actually interpret dates and times. And so you can even, it can keep track of different time intervals, and it has a lot of real functionality. I also find sometimes the date time can be a bit confusing in Pandas, but it is well worth figuring it out in my experience, because it is very helpful. Let's see, I got a question. Yeah, so Mumita, you asked, I'll pause here if anyone else wants to ask a question before we go on, please do. You can either ask it verbally or you can write it in the chat. So Mumita asks how to just extract a list of data from an online database into a Jupyter notebook. So that is usually quite simple, but it really depends on where the data is stored and how the data is stored. So in this case, it's essentially what I've done. So here, this CSV file that I loaded in is one that I have on my computer at the moment, but I just downloaded it from online. This was free data that I got because I was curious to look at Canberra's temperature data. And so I downloaded it to my computer and I typed this command. Like, this is what I actually was looking at this data, not just for this school. I was looking at it for something else. And I typed this command and then I did T so I could view all of the data here. So this is one example of doing that. But yeah, more generally, it really depends on the type of data and where it's coming from. So if you have it downloaded, so I guess, yeah, so I guess it's hard to answer because it's it depends. Sometimes it's hard to download the data or it's hard to figure out what data you want. I don't know if any of you went yesterday. There was a tutorial on kind of publicly available and freely available data. I don't know if they recorded their session. I haven't seen the video yet. If I do, I'll post it on the website. But they do have, pull it up here. They did post a list of resources, which you can also find also on the website. And so here has a list of free, publicly available data that's related to ocean and climate science. But the problem with a lot of this is that each one has their own way of storing the data and accessing the data. So I would really like to, and I didn't for this mini school, if there's interest from all of you, it would be really great to go through a lot of these ones that might be of specific interest to you and actually go and figure out how to get data out of these. The other side note, I'm probably talking way too much about this, but this is something I'm quite interested in. So I actually started a postdoc a few months ago working with someone who's, we're working with this group called Pangeo, P-A-N-G-E-O. I can pull that website up too. If you haven't heard of it, it's quite interesting. So it's a community platform for big data geosciences, as it says here. So it's basically a place for people who are interested in Earth and geoscience and who are interested in coding as well. And so the idea is to have a community so we can support each other, but so also we can develop tools that are useful for one another. And all of them are free and open source. And open source means that anyone can help contribute to them. So even you all can help contribute. I would love to go into more detail if you have more questions. I probably shouldn't derail this conversation too much, but one of the goals of this project is to make it easy to access data. So what I was just saying, where every place has its own way of storing the data and accessing the data, it gets very complicated and very confusing. Like, I have trouble figuring out how to get these different data sets. One of the goals of Pangeo is to get rid of that difficulty for everyone. And how they're doing that is by using Google Cloud. And I don't know if you're familiar with cloud computing and cloud storage, but basically it's a place where we could store, if we could store all of our data on the cloud instead of on local machines. So like in the case of the Python lab that I'm just running, I have data stored on my computer. So when you run it, you'll have to download that data. And that is also available on the website. It should all be explained. And in the cloud, it would be stored and we could all access it because we're all able to access the cloud, whereas you all can't access my computer. So it means that we could all access the data in the same way and we don't have to download it to different computers and figure out how to access it. So anyway, that's probably all I'll say at the moment, unless you want to hear more. But I'm really hoping to involve Pangeo. I think a lot of people are interested in meeting lots of you and helping, kind of get computational science off the ground. So yeah, that's my little plug for Pangeo and cloud computing. Cool. are there any other questions before I go back to the Python lab?
May I ask a question?
Absolutely.
Okay. This question is about two parts. The first part, how to encode the high temperature and high pressure in oceans. If I'm making a device, how to make a program for it, such as int high temperature, int high pressure, and I want to save this data. How to make this?
Okay, let me just make sure I understood correctly. So you'd like to, are you trying to find a data set that has pressure and temperature? Is that right? Ocean pressure and temperature?
Yeah,
So you're trying to find a data set, or are you trying to create one?
I intend to create one.
To create one, like using your own measurements, or is this, you want to use some satellite data or some data that already exists?
I want to make something like that, a device like that used to measure high temperature and high pressure, and I want to save data.
Okay, so if you, so I guess if you're making your own data set, like if you're going out and taking temperature and pressure measurements, then you can record it somehow, like in Excel or something like that. And then you can save it as a .csv file, for instance. And then you can load it in to Python using Pandas, like we're doing here. Yeah, if you're, I'm probably not, I can't answer too well if you're trying to find some data that already exists. Because I don't know offhand what data is available and has what you would need. But there you could look at that list that I was showing here of freely available data, and you could see if it has, you can look them up online and see which ones have the right regions of the globe or the right variables that you need. But yeah, if you're trying to make your own data set, as I understand what you said, correct me if I'm wrong, then the making of the data set, you don't, so you can make a data set in Python as well, but mostly that probably just means entering numbers. So it'd be very similar to writing it in Excel or something like that if you have it. You could do the same here, where you could just define arrays and just say, like, entry 1 is day 1 and then day 2 and day 3 or whatever. So yeah, I don't know if that kind of helps answer your question. Yeah, let me know if not. Yeah, or feel free to elaborate on that maybe at the end. Okay, any other questions? Okay, not hearing anything, so we will keep going.
Hello.
Yes, hello.
Yeah, Madam. Yes, you made mention of how to use an online database for personal work or anything of the sort. Briefly, you mentioned something of the sort, how to, just as you create your own data sets in the CSV files format, is it possible that you can also import data from a particular database online and make use of to plot graphs, etc.?
I think so. So you're asking if, sorry, I guess, are you making your own data, like you're going out and measuring it yourself, or you're getting data from somewhere else?
Yeah, somewhere else. Let's say known database online.
Yeah. So you can absolutely, so that's exactly. There are all sorts of places that have lots of data online, and you can download them. In fact, a lot of them you have to download to your own computer. And usually they will be in the format of a CSV file or a netcdf file, or something like that. And there are different ways to handle that. So a CSV file or an Excel file, you can handle in Pandas really well. A netcdf file often has multiple dimensions. And so if you have ocean data that's X, Y, Z, and time or something, so like 4-dimensional data, then it often is saved as a netcdf file. And then you can handle that with the netcdf4 library, which I think I mentioned here. And so there's basically, Python has a way to load in almost any type of data. You might have to Google it if it's a type of data I didn't mention, and maybe it's a bit less common, but there will almost always be a Python package for your type of data. I don't know if that answers your question. I feel like I might have gone on a tangent. Was that what you were asking,
Yeah,
Adam?
I'm getting you.
Okay, cool. Again, feel free to elaborate more later or on Slack if you want to have more of a discussion, text-based discussion.
Okay.
Cool. All right, well, I will continue, but again, you can interrupt at any time with questions. So now we're going to plot. So, we loaded in the data, we can kind of visualize it a bit, but it's nice to visualize it somehow so we can actually see what the data looks like. So we do that by calling the matplotlib pyplot library. So that's PLT. And then we do dot plot. And then here we're saying we want this T data frame, and we want to plot the temperature. And so when I run that, then we get temperature, which is about what we would expect temperature to look like, because we have this yearly cycle, right? And we can see here at the bottom that we're kind of 1,000, 2,000. I'm not quite sure what that means. That isn't very meaningful. So we can say plot basically X comma Y. And in this case, X we want to be the date and the date. So if we do it again, now we can see it's the date. And so this is in years. But we still don't have labels on these other places and the plot. And so it's always a good idea to label your plots. So first of all, what I'm doing up here is increasing the figure size. So you'll see when I evaluate this cell, it's a much bigger figure. And that's because of what I did up here. This 12, 4. So it's 12, I think it's supposed to be inches, but it depends on the resolution of your screen. So you've got 12 by 4 in height. Then I do the same plotting as I did before, but I'm adding some labels. So I do plt dot, again, accessing matplotlib library, and then title. And I created this title. So I put temperature in Canberra, Australia, degrees C. This is a little fancy notation here. If you're familiar with LaTeX, this is what I've used here. And so this is an example. If you don't know LaTeX, totally fine. If you do, then you can see that the Python plot and anything that you use in this case interprets LaTeX. And so you can do nice things here, like create that degree symbol. So that's pretty nice. And we also do an X label. So I'm saying year, and then a Y label where I say degrees Celsius. So I use that LaTeX again. And I can decide the font size. So, if I delete this and say font size should be 50, now we're just gonna have a giant label over here, 50. So all of this you can control. Oops, 165, that would be big. Okay, this is a bit more about LaTeX. So here, I'll let you read the LaTeX part later on your own. Here we're using a function from the NumPy package, which is which I'm abbreviating NP, and then I'm taking the mean of the data. So this is the mean in time, and it prints out what the average temperature is. So 21.36 degrees Celsius. So yep, this is just related to what's up here, so you can read that and see how they're related. Okay, so we can make our plot look slightly nicer. We can here, so we're using this margins function here, and that means that we're aligning the axes with the exact values of the data that we have. So if we go back up here, see we have all this white space on the left and on the right. Sometimes it's nice to have white space. I find usually if you're trying to create a plot for a paper or something like that, you have kind of limited space and you pay for each figure and things like that. So you really want to use your space wisely. So if I evaluate this, we can see that there's now no extra space there. And you can see that I changed the color. And that was done up here with this color command within the plot function. And so I said color equals dark orange, and it actually knows what dark orange is. So you can play around with that. I think that's what this challenge is here. So you can test your knowledge. So the first thing, I'll go ahead and do this one just to show how you can copy and paste a cell, because that's very useful in Jupyter. So I say copy and paste the above cell. So if I highlight this cell, we can see that it's highlighted because it has this blue rectangle. And oops, I'm going to have to zoom out to do this very briefly. If I go up to this upper panel, there are a lot of useful buttons here. If you don't know what they are, you can just hover over it. Wait a second. And now you can see that it says copy selected cells. So I'm going to click that button. Now I will highlight this cell and I'm going to paste. So now you can see I just copied this cell, this orange graph, into this bottom cell. And now that was the first part of this challenge, was to copy and paste the cell. And now we're going to switch the color. So I said, for instance, you can type red. So here we could type red. And ta-da, it's red. I'll zoom in a bit again. We can type all sorts of colors. Let's see if it knows lavender. I don't know if it knows lavender. Yep, there we go. Now I have it as lavender. So not necessarily super helpful, but I actually find visualizing data is really important, and it can get your paper much more interest if you have really nice graphics. And I would say, I'm sure you all know this, but don't go overboard with different colors, as I often like to do. But sometimes it can be very useful to choose specific colors that contrast with one another if you have two lines in the same plot. So sometimes it actually does make sense to think about what colors you use. Okay. So now we are going to look at the trend in this time series. And so these are all just items that I came up with, partly because these are things that come up in my research a lot. And so hopefully this is helpful. Yeah, I think Titus, hello again. Reminder that, yeah, feel free to ask questions at any point. So we're going to look at the trend of this signal, especially in things like climate time series. That's really important because the trend is kind of the trend of like global warming, of the increasing temperature, for instance. Or if it's not temperature, it might be some other signal, if winds are increasing in a certain area because of climate change, that kind of thing. And that would often be seen in a trend. So to look at a trend, it's actually quite easy, but we need to import a new library. So in this case, we're going to take the library SciPy, which is like scientific Python, and we are going to import just one function from it, which is called signal. And so that's why here, instead of typing import, I'm saying from. So I'm saying I want to access the library SciPy and import it import just the one function called signal. I could have just as easily said import scipy and then typed here scipy.signal. They're equivalent. Sometimes you want to do one, sometimes the other. That's why I show two different ways of doing it. But in this case, we just want the signal function. And we are going to, within signal, we are going to access the dtrend function. And so this will take the trend out of our data. So in my work, I actually, while trends can be very interesting if you're looking at like global warming or any other kind of trend, I actually often want to take the trend out because I'm not interested in that. I just want to look at the variation over time without considering that trend. So here we're just going to take the trend away and let's see what happens. Oh, it says, oh, so this is, yep, good. So you can see I have an error message, and error messages can be very good. So, I mean, it means you do something wrong. That's true. But it usually, they're very helpful. And so you can find the error right away. So in this case, it's a name error, and it says name signal is not defined. I can be like, oh, that's weird. I totally imported signal up here, but then I look over here and there's no number, which means I forgot to evaluate this cell. So all I need to do is evaluate it. And now let's see what happens. So now I got a different error. So you can see here, there is a lot of kind of garbage here. So when I said errors are usually very helpful, they are, and usually all you need to look at is this bottom line. So this all has almost too much information. So if you're a developer, then maybe this is useful. But even for me, I usually don't look at this stuff. Occasionally I do. The only other thing that's useful, so that might be useful other than the bottom line, is this top line. And notice it has, here it's a bit, like it doesn't actually help much, but you see that it has this arrow. This arrow points to the exact line where the error occurred. And so if I had had 10 lines of code here when I evaluated this cell, it would have pointed to this line. So that's very useful because it tells you which line the error is on, which in this case is obvious because there's only one line. So anyway, this error is saying array must not contain infs or nands. So infs is basically the kind of computer way of storing infinite values, and nan is not a number. And so it's saying in this data set, there are some infinite or not a number values, and we don't know what to do with them, so we can't do dtrend. So what we can do, this is a little bit of kind of fancy footwork. And I have to say, when I came across this, I was like, oh shoot, what do I do? I Googled and kind of figured out the best way. So I use Google a lot. That's one thing, these error messages, they often tell you what it means. If you still don't understand, which happens to me lots of times, then I just copy this last line and I will enter it into Google, and there are often, usually, lots of answers for me. So what we can use is this function called isNA. So that's kind of like is not a number, like is there a not a number in this variable, in this case, this column of our data frame. And notice it's a pandas function. So if I evaluate that, we can see the result. So we see true, 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 and then we see some falses here. So true, when we're basically we're asking the question, is the value in this column a nan? And in this case, it's telling us, yes, it is. That is a true statement for these. And if I scroll back up to see our data in the data frame, here, so we can see the top 5 rows here. If we look at the maximum temperature, sure enough, they're all nans. So that makes sense that it says true. We can see that. Where was I? So this tells us which values have nans and which don't. So we're going to create a copy. So we're going to, this is, it's just so we don't overwrite the data. sometimes it might make sense to overwrite the data. And I guess to be clear, when I say overwrite the data, I'm saying overwrite the data that we've imported into Python. You won't overwrite in this, by doing this, you won't overwrite the original data. So that's important to remember. But sometimes it's good to make a copy and just do your calculations on a copy. So that's what I've done here. I've defined a new column called T_dtrend, and it's just a copy of the temperature, but it will be a detrended temperature. So I will evaluate that. And now I just printed out, I did T.head, so I printed out the top 5 rows. And you can see over on the right, I have a TD trend, which for now is the exact same as this column. So now we do a bit of fancy stuff here. So now we say T, so in this column, T_dtrend, we want to find all the values that are not, this tilde in Python means not, that are not Nands. Did you have a question, Adam?
May I ask a question?
Oh, yeah, of course, yes.
Thank you. By using Python program, it is permitted to save the data set according to the priority, and sometimes, for instance, the files of high polluted area, for example, when I make a priority to save data, it is permitted to do so by using Python?
Oh, I'm not quite sure I mean by saving by priority. But you can group your data. So basically, once you import data into Python, it's pretty powerful. You can pretty much do whatever you want with the data. So you can organize it specifically. So here it's organized by date. You could organize it by the temperature, or group them in different ways, or you can split it apart into different regions of the globe or anything like that. Was that what you were asking?
Yeah, I'm asking about that.
Okay. Yeah, so Python is very powerful. Most things like that you can absolutely do. This is where it's nice to know kind of how Python works generally, like the basics of it. And that's really what these will do. We're getting a little specific here, but most of this is kind of a bit more general, though this is very specific to the Pandas library. But yeah, if you Google, you can find so many great resources. So if you say, group data by something, it'll tell you how to do that. So Google is your friend. That's my upshot from today. So anyway, this is a bit fancy. So I probably won't go into it much because we don't have that much time left. But this is basically saying, detrend the data that is not a NaN. And so, as it says here, you may have gotten a warning, but that's okay. So this is just a warning. It's not an error message. But it says, yeah, so here it has setting with copy warning. It's like, oh, you're trying to do this. We don't have to worry about that for now. Sometimes you want to worry about warnings, but warnings aren't errors, so you can always keep going. Sometimes you'll get a warning that says this function will not exist in a new update. And then that's probably worth paying attention to because I often ignore it and then it updates and then I can't use that function anymore. But again, it's just a warning. Okay, let's plot. Let's see what this plots. So we have two things plotted. The top one is the original time series. The bottom one is the detrended time series, and they look very similar. But notice that here, the series, the bottom one, the time series starts around 0, whereas this one starts around 23 or something. So that's what we did by detrend. We basically took out the average line at average temperature at each point in time. And this also is a nice little subplot if you want to put two plots together. You have a few other challenges that you can do, which I will leave them up to you. You can always ask questions on Slack, and I encourage it. I actually really find Slack, other people might have the same questions as you. And so don't be shy to ask questions. It often helps everyone else. Hi, Ebenezer. Welcome. You're kind of jumping in the middle, but feel free to ask questions if you have any as we go. Okay, let's see what this plots. I don't remember. Okay, so this is plotting the actual trend. So we just took the trend out, and this is what the trend looks like, which unsurprisingly, because of global warming, we're seeing basically a steady increase in temperature over time. This is actually quite an interesting trend, that it's very straight. But that's what we took out of our time series. So we had this time series that kind of did this, and we basically flattened it out. Okay, so you have more challenges here, and you have some more fancy plotting things that you can do. Maybe I'll show, I think I have to, I can show you some of these. You can go through them slower on your own. Let's see if we get through it. So here we have two different things on the same, let's go to the next one, it looks better. So here the red is the temperature, and this black line is air quality. So I was actually plotting this for my own enjoyment, because I don't know if you all remember, but there were some really bad bushfires here in Australia 1 year ago, the beginning of 2020. And the air quality in Canberra was just terrible. Like it was just thick smoke for like months. And so I was curious if that air quality had ever really happened before. And here we see that for the last like 5 years or so, it was very good air quality, a few days that weren't. And then it just got really bad here. So I was just plotting this for fun. And you all get to.
Hello.
Yes, Paul, hi.
Cool. Elizabeth, I'm wondering if like how we could like import our data analysis. Maybe we are taking samples, raw data. We put it in Python or Anaconda, and we analyze the data, and we have plots such a map. How are we going to like export it from Python to maybe Microsoft Word or Excel for our presentation?
Okay.
Yes. Do you get me?
Yes, I think so. You mean like figures, for instance?
Like this
plot?
Temperature, yes. Like what we are seeing. Like how are we going to import it to maybe Word
like a PowerPoint
or
PowerPoint or something.
PowerPoint,
Yes,
or something. Yeah.
That is a great question.
Secondly, I'm wondering if we will have an exercise, like you take us through an exercise. For example, raw data on maybe temperature or sea rise or something. We have collected raw data, and how we are going to like analyze this in Python. Like I don't know whether you have something of that sort.
Yeah. So this basically is what this Python lab does. It's rather simple data. It's just temperature data, so I don't do much to it. And I don't remember if you were here at the beginning, but basically all we did for this Python lab, which is available on the website for you to do yourself, is that we take raw data, raw temperature data, and air quality data here. And well, the temperature data, we didn't have to fix much. We took a trend out of it. And then we plotted it. So this is a very, I guess, basic example of how to do that.
Okay.
Yeah, but yeah, how you, there are lots of different data storage types. So I chose a CSV file for this lab because a lot of what I was guessing you all come across are CSV files or something similar, which is like Excel data. Or data that looks like Excel where you have lists. But I also run into netcdf files a lot. And those are very common in like climate modeling because you have multiple dimensions. And you can see a few very basic examples of how to open netcdf files and do some math on them and plot them in the COESSING 2019 Python lab. So if you go to the COESSING website, here, You can go to past schools and this menu shows up. If you click on 2019 school, it's loading, there we go. And then you can scroll down. So we have a Python lecture, so that has some useful tips.
Okay.
And Python lab. So you can download this zip file because it has the data and the Jupyter notebooks and Python scripts that you need. And that actually does open a netcdf file if that's one that you're interested in. If you have a specific question and are having trouble with a specific data type, you can let me know. I haven't used too many others, but we can maybe Google it and figure it out together. Happy to help.
Okay, thank you very much.
Your first question was a very good one and one that I definitely should include in this lab. So I'm glad you asked that. So let's say this is your final figure and you're like, this is great. I want to show this in the presentation or my lecture tomorrow or whatever it is. Now it's in this notebook, which is nice. And actually one thing I will mention is if I close this notebook right now, this plot will stay. So if I open the notebook again, I don't have to rerun everything. The plot's still there. So that's really nice. So I often use these notebooks as like lab notebooks. So I take notes, even if it's not something that I'm trying to make for publication. I just kind of say, here's what I did today. I made this plot. Here's what I think looks good. Here's what doesn't. And I can just open that up kind of like as a journal. And I don't have to rerun it every time. So that's good to know. But sometimes you don't want it in here. You would like to put it into a presentation or paper. So then you would want to save the figure. And you do that by typing plt. So that's matplotlib.pyplot.savefig. So save figure. And then we can call it Canberra temperature fig or something like that. And then you put the extension that you want. I usually save as PNG files. You can do JPEG and a few others. And so if I evaluate this now, so we can't see anything different here. It looks the same. But if we go back to our home page and we can click here, last modified, it hasn't showed up yet. That's probably because I'm in a different folder. Okay, I need to navigate to this right folder, but then we should see what I just saved. There we go. So I must be in the Python lab folder here. And then we see the Canberra temperature fig.png, and you can see that it was just modified seconds ago, which is correct. And you can even click on it and view it here.
Okay.
So yeah, that was a very good question. I should definitely add that to.
Thank you very much. Yeah, very interesting.
Yeah. So these are great questions. And I think several of you have asked about what you do when you have like either how to kind of format your raw data and be able to analyze it in Python, or kind of how to go from the raw data to making a plot, which is what we do here. But maybe more examples of that with different types of data would be useful. So I actually, if any of you here have data that you use or that you would like to use, and you want to share it with me, I'm happy to use that as an example, which might be really useful. And that way it benefits you and me, because then I know that I'm not making an example that none of you care about. And then hopefully that will actually help you because you can actually see how we could do it. So you don't have to send it to me now, but at any time, I would actually be very interested to know what data you're working with, because that will help me to tailor these tutorials as well. So please feel free to reach out, ideally on Slack or by email. And that would be really helpful because I do plan to keep doing these at future events. So the next one will probably be in August. But as I said, I'm on Slack. And for some of these small things, I'm really happy to help. So if you want to share your data with me, please do. I think that will be really cool.
Thank you. With the data interpretation, having plotted the data such as this, what is the data saying? Where, for instance, you want to write a paper, how do you interpret these data in your paper? Can you briefly say something little about these information on the data here, on the plot today?
Yeah, so this is, that's a good question, and one that it takes kind of time of looking and playing with your data. So what you're asking is like very much a data science-y question, which I know you're interested in.
Okay.
So it really depends. So here, I was just saying, here, let's plot some data and let's do this. Normally, when I do my workflow, I will do something like this, where I just kind of say, well, I'm just going to plot some data and see what I get. And that's kind of the first step. But once I look at the data, then I can say, oh, that looks as expected. There's nothing interesting there, but oh, this looks interesting. There's this aspect. So in this specific case, I'm not sure. So the D trend might be interesting, that there's a very noticeable, we saw further up here, I forget where it was. Yeah, here, that there's this very noticeable trend. So the average temperature is increasing. That might be interesting. Maybe you're not interested in that at all. Maybe you're interested in comparing, how air quality is affected by temperature. So here we can see this air quality kind of peaks at the same time that this peaks, which is like the peak of summer. Here we can see another peak in air quality, which is when this temperature peaks here. But then here we see a peak, and we don't have a peak in temperature in the same here. So maybe we don't. I'm just kind of like throwing ideas out, thinking out loud at the moment. So here on this plot, I plot this gray line, which I believe is the like safe air quality or something, or like beyond this, it's like extremely dangerous. And so I plotted that just so I could see how much worse we were for several weeks. And we can see that, we went from 200 being the like, if you're above 200, it's terribly dangerous, and we were at 700. So I was trying to plot this to show just how extreme the air quality was. So I guess that was my main goal in making this. And you can see just how extreme it was by seeing how it's, air quality is fine, it's fine, it's fine. And then it's just terrible for a couple months here. And it had never been that bad in the last 5 years. So I was trying to make that case. So it's really a like back and forth conversation of like, what do you want to, what is your data telling you? And how can you best show that and highlight it without distorting your data? So not a very specific answer for you, Adams, but
It's helpful.
Yeah, okay, hopefully that gives you an idea.
Yeah, it's helpful,
What other questions are there? Jonathan, welcome. I saw you just joined. Hello.
Yeah.
It's good to hear your voice. How are you?
I'm fine. And you?
I'm good. You're probably just as much of a Python expert as I am at this point.
Oh, no, not really. I'm still learning from you.
Well, I'm still learning as well. So
we're all still learning. We tried to start something in Ghana, but because of COVID and access to internet, the students couldn't continue. So for some time now, we've just been chatting on WhatsApp. So hopefully I can get some of these materials to them.
That would be great. I'd be super interested to help. I started a postdoc a couple months ago working.
I wrote GRE and TOEFL, and now I'm in South Korea. I'm doing my master's.
Oh my gosh! Wow, South Korea. Okay, well, I won't have.
That's why I was off for some time.
Oh, you know what? I'm in Australia, so you and I are on very similar time zones. So it's late night for you as well.
Yeah, it's night.
Yeah, it's 10 p.m. here. So yeah, you and I are on more similar time zones than everyone else here. But yeah, it would be great to chat. I don't want to take up everyone's time by chatting with you at the moment.
Okay,
but
so no problem. I'll just send you.
Yeah. I'm on WhatsApp as well. If you want to find me there, or you can email me.
That would be great.
I can message you or let you know what my number is.
Yes.
Yeah, so do you or does anyone else have more questions here? While you're thinking of questions, there are a few resources that I wanted to point you to that are really good. So I made some of these, but so many people have so many good resources out there that yeah, it doesn't make sense to recreate all of them. So, but I want to share them with all of you. The other thing I can do, I'm happy to stay on if others are interested. I could go through kind of the basics of Xarray and Dask. They're very specific libraries, so I don't know if that's useful at this time. Again, these are all available on the website, so you can go through these at any time. I'm just having a few suggestions if anyone is interested. I currently use cloud computing for my research, so I could log in and show you a little bit. It doesn't look different at all, but I could show you a little bit about what I'm doing there. So yeah, if you have anything that sounds good of what I just said, let me know. I'm happy to stay on for a little bit longer. And I see that
troubles installing Xarray. The last time I tried to make Anaconda install Xarray, I had a lot of troubles. I think maybe it was too big. The Wi-Fi wasn't fast enough. I think maybe.
Okay.
I tried several times, but I couldn't.
Okay, bummer, because Xarray is amazing. Just in a nutshell, Xarray is in some ways it can be it's actually quite a complex package library, but it has so much power. You can basically plot. So I don't have. So here's an example, I guess. In one line, I can take the SST variable, so the sea surface temperature variable from a data file, take the mean in time and plot it. So normally you'd have to do these all as their own steps. And here I can just do it all in one line. And so Xarray, the goal of Xarray is basically to make, well, there are a few goals. One of them is to make loading in data and like visualizing data or doing simple calculations very easy and very quick. So yeah, so that is really nice. The other really nice thing about it, which is here. So here, when I'm saying dot mean and take it over time, this is also really useful. So so Pandas is also quite similar. But if you just started from NumPy, so the numerical Python library, it doesn't know which axis is time. It just knows that there's, maybe there are 3 axes. You have X, Y, and time. So how something moves in a 2D space in time. And in NumPy, it'll say, okay, you have 3 axes. So you have axes 0, 1, and 2. And you have to remember which is which. And you have to say, oh, I remember that time is axis 2 or whatever. In this case, Xarray uses metadata from your data set. And for those of you who don't know, metadata is like how you label your data. So when we were in the Python lab and we were going through here, when we had, for instance, year, month, day, maximum temperature, this basically is metadata saying that this is the temperature here, but there are numbers, but we have it labeled as temperature. So Pandas also does this, uses metadata. And here it says date time. So, oh, Mabel, it was good to see you. I can email you my WhatsApp number because I have your email. This uses metadata, and what Xarray does is it uses metadata very smartly. So it'll, if you have data that says this axis is time, this one is X, and this one is Y, it remembers that, and you don't have to know which is which. You just say, take a mean over time, and it will do that. So it makes it much easier to work with, where you don't have to keep remembering the ordering of everything and all of that. So, but for it to work well, you need to make sure that your data has good metadata, which is not easy. So, yep, cool. Looks like several of you might be ready to tune out, which is fine. It's been over an hour. So yeah, I appreciate you all coming. For those of you who aren't about to leave, I do want to mention there's this thing called Ocean Hack Week. And I have yet to do this, but I will post a link to this on the website and in Slack. Yep, will do, Adams. Sounds good. And so it's I'll send the link out. But Ocean Hack Week is basically all about computational ocean science. And it's meant for people who don't necessarily have much of a computational background. And so they have lots of really incredible, this past year was all virtual, of course, like everything. And they have really incredible videos and tutorials and all of Jupyter notebooks. They actually have some R notebooks here. So Paul, I think you were asking about that yesterday, maybe a few others. And so, yeah. So I can't help with R at all, but you can see they're very similar. They're using Jupyter and R in the same thing. So
I just started learning R.
Yeah, nice. That's funny. I know very few people who use R, but they're very similar languages. So yeah, I would say choose one and learn it, and probably choose the one that your specific field is using. So in ocean and climate science, that is definitely Python. But if you're in a different field, it might be R.
Right now I have access to MATLAB, but so will you advise, because I have now, because of the institution I'm in, they bought MATLAB for me. So, but I don't know, like, will you advise me to move to MATLAB or I should stick with Python?
So I would say stick with Python. The problem with MATLAB in my mind, so I have nothing against the language of MATLAB, and actually it's quite nice. You double click it, it's open, and that's a bit easier than handling Jupyter Notebook and that kind of thing. So I understand that it does have some benefits, but in my experience, so MATLAB, you have to have licenses for it. You often have to pay for it, or you have to find a bootleg version or something, which can be challenging. Maybe we're all very good at that. And it's proprietary software, so which is not open source. So open source software, which you might hear that term a lot, and Python and R are both open source, means that anyone in the world can contribute to it. I've started to do that. I encourage all of you to get involved. It's kind of a nice community. That's something we can talk about as well. A lot of this happens on GitHub. I don't know if you've heard of GitHub, but that's a website where developers create like open source software, basically, for the benefit of all of us. And so it's not, by all means, you do not have to develop. You can just use Python, and that's great. And the nice thing is that most people, there are so many people who use like Python and R that if you look up, if you're trying to do something specific, like on a climate model or something, someone has probably written a package that would be useful for you. In MATLAB, that's not necessarily the case. It may be, but it's a bit, because it's proprietary and it's kind of behind a paywall. I think the community, it's less of a community, I guess. So I really feel like, especially in places, so I don't know what Korea is like. Maybe in Korea you have, all the schools have funding to have MATLAB. But in places like Ghana, when we were there, and in a lot of places around the world, or even like, I have access to MATLAB through universities, but I had a gap this year where I had a few months where I was still trying to finish some papers, but I was no longer at a university, and so I wouldn't have had access to MATLAB. So even, it's really nice having Python because I always have access to it. And I can put it on my own computer easily. And it's a lot easier to run on supercomputers if and when you get to that point, or on Google Cloud or Amazon Cloud, on cloud computing, which is something I actually hope to, those of you who are really interested in Python, I really hope to kind of get you started with cloud computing, because I think there is a real potential there, especially for West Africans. So I'm hoping in the next year or two, since I'm doing a lot of cloud computing now, that we can start cloud computing. And that you can, it means that you all would have access to big data sets and be able to run like analysis on very large data sets without needing a big computer yourself. So I don't know if that answered your question. So obviously you can keep using MATLAB. That's fine. I won't judge you, but
I think I'll stick to Python, because definitely I'll be done one day and I'll have to leave.
Exactly, and that's so the other thing is they are similar, so it's not terrible if you're doing MATLAB for now. I started with MATLAB in college, and then I went and spent a year in Germany. And the Germans were like, no, you should use Python. And I was like, whatever, I don't know any better. And I started using Python. And then I came back to the US, and I was the only person in my research group using Python. And by the time I was finishing my PhD, everyone in my group was like, oh, I wish I knew Python. You're so lucky. And this, I've heard this from a lot of people. So, everyone's different, but yeah, I think right now the momentum is really in Python.
I'm trying to learn like more of the codes and be familiar with more of the codes. I'm reading a book, Think Python. Or will you recommend any Python book, like learning more?
Oh yeah, I actually don't know. I haven't read any books on Python myself, so I can't recommend any. I mostly have done my learning online, so I'm reading online, and if you go to, this is the COESSING website again, and you go over here to resources, there are these Python and Jupyter Notebook resources. So a lot of these are kind of Python learning. So here, I kind of write what they are. You can read tutorials, watch instructional videos, and take quizzes. There are some text tutorials. So you can kind of walk yourself through learning these things. There are video tutorials, and then there are some online courses. So those can be really good. But I actually haven't read a book, so that's also great. If you have some good books, let me know. I can add them to this resource list.
Thank you. But I saw that Jupyter Notebook at least provides some kind of information. Like if you go into Jupyter Notebook, there's some places whereby they explain some of the packages, some of the libraries, and how they work.
Yes, that is a great point. I think what you mean is something like, actually, let's see. I'm gonna go further up. So I haven't used this for a while. So if I type read CSV question mark, let's see. So if I am like, ooh, I think I want to use this function, but I don't know how it works, you can type the function with a question mark after it, and then it pops this up and it says, this is how it works. This is a bit, it's a lot here, but this is basically saying all the different things that you can put into it. And it says what it does. So it says it will read a comma-separated values, or CSV file, into a data frame. And it tells you all of these things. And it tells you what they all are. So it says, when we say file path or buffer, it is a string or a path to an object, which here it is. Okay. Yeah, so that was a great point. So you can use this question mark, which is really useful. What else is there? I feel like there is something else that I've used before, which has a little walkthrough of.
Is that Anaconda?
Oh yeah, you can do a user interface tour. This is Jupyter Notebook that was downloaded via Anaconda.
Yeah, well, but like if you go, Anaconda also has a package whereby they explain the various like Jupyter Notebook, PyCharm, right? I think the updated version of Anaconda Navigator.
Yeah. Okay. Yeah. Absolutely.
New libraries. Yeah. So they like explain how they work in general.
Yeah. That's a good point. If you have a link to that, to those let me know. I haven't explored this very much, but yeah, Anaconda is a great resource. I actually was on a conference call earlier today, and someone there works at Anaconda. I was like, whoa, cool. So yeah, it's a really great company that's really helping open source software, as we can see. And so yeah, it probably has some really good write-ups. Here it has a little bit about these different packages here. So I also want to make sure I get to Mumita's question that she asked me, which is about Google Colab. So Google Colab, you need a Google account. And if you have a Google account, you can access Google Colab. So let's see if I type Colab. So if you go to this link, which should just be on the COESSING website, in the Python programming tab, colab.research.google.com, then it opens up.
Hello, Paige.
Yes, yeah.
Paige, you show me the tutorial in the last summer school.
Yeah, okay.
But my question is, we can do the Python programming in Google Colab, but what can we do other than this? Actually, this I was asking.
Like, can you use R or something? Is that what you mean?
R or anything else can be done with using Google Colab, or it's just for the Python programming?
You know, I don't know the answer to that. That is a very good question.
Because all the options I've gone through, they're related to Python only. So I was curious about that. Is anything can be done other than Python?
Yeah, it's
using this.
Possible. Okay, well, here we go. There are two ways to run R in Colab. It looks like there's a library that allows you to use R functions. The R runtime. Well, it might be possible. Yeah, that is a good question. So in Pangeo, what I was talking about before, which is this group that I'm part of now in my new postdoc, it is all Python based. So Pangeo has its own cloud deployment. There's a reasonably good chance that in a future school, maybe later this year, that we will be using Pangeo Cloud to do our Python programming. And that is all in Python. Maybe at some stage they plan to expand, but because the vast majority of people in ocean and climate modeling and data analysis use Python, they've just focused on Python and tried to make that really, have really good tools in Python. So yeah, so some places just use Python, since that's what people use. But yeah, so looks like this is if you want to use R and Python, but we don't want to do that. If you want to use R, you can go to colab.r. So yeah, it looks possible to use R. I'd have to Google other specific languages. Yeah, that's a good question that I don't have a great answer to, but Google can help. I don't know R, so I don't know how to test if this is R. Yeah, I guess I can see. Yeah, okay, so it's not Python because it doesn't know NumPy. So yeah, this might be an R. I can send that link if that would be useful. Cool. Yeah, so there's so many great resources. There's another one that I found that, especially this past year, because so many schools and universities had to do all of their teaching online. A lot of people have some really good online complete courses that are just kind of freely available. Sometimes you can't necessarily watch the lectures, but they have all of the materials, like all the Jupyter notebooks that you can walk yourself through. And I found one person, I was Googling something and came across someone who is basically writing a textbook about, I think, ocean modeling, maybe climate modeling in general, using Python in Jupyter notebooks. So each chapter is written as a Jupyter notebook. So it's like content about the theory of modeling and all of that. But kind of interspersed is coding. So it's like coding right alongside. So I'll have to find the link to that and I can post that in the resources page on the website. So there are a lot of really cool resources that are out there. Yeah, it really is interesting. I kind of want to go through it myself. So yeah, I will try and add all of these resources. If you find good ones and you think others might be interested, send them along or post them on Slack. That would really help everyone. And yeah, that would be great. I'd be happy to do that. Okay, I think that's most of what I was going to go through today. Any other questions before we call it quits? Before we, well, while you're thinking of questions, if you would like to be added to the Slack group, send me your email via this chat and I will add you to it if you're not on it already. And I'm on Slack all the time. I use it for my own research, or my own research group has a Slack group as well. So I have Slack open a lot, so I should answer relatively quickly. And this is the COESSING Slack group. So if you're not on it yet, I can add you. Somehow I'm not able to copy that. There we go. Yep, so any questions while I get people's emails here? No more questions? Okay. Oh, yeah.
I just wanted to ask you a question. Like in terms of, but I'm using the satellite data, just making analysis and stuff like that. But like last time, what I and Christian did was that we made a video. So, but I think this is very different from making a model, right? Like running a model, doing something in addition to a model, like an ocean model.
Yeah, sorry, I didn't quite catch what your question was. Was like making videos of models?
Like what we did was that we took satellite data and we just ran it to, and we made images, like a set of images, and we just put them into a simple, we just like play the images like slides and just make a video.
Yep.
Which look like basically when you watch it, you feel like the sea surface is rising and like moving. Yeah, it's just images at a high speed. But like how like this, I think this is very different from making a model, like in terms of modeling.
Yes, it is different than making a model. But yeah,
have you done anything in relation to? Have you done any modeling with Python?
No, so mostly what I've done is data analysis in Python. Sorry, all of what I've done is data analysis in Python. The model I used, the ocean atmosphere model I used in my PhD was a Fortran model. So it was written in Fortran. You'll find a lot of climate models are written in Fortran, partly because Fortran is very fast. And Fortran was really popular in the last decade or two, and that's when most of them were written. Yeah, so I haven't written a model in Python. That being said, if you're trying to like writing a climate or ocean model, it can be quite challenging. Or I guess it can be as challenging as you want. But if you're just doing a small calculation, and you can do, so what you define as model actually can vary a lot. So you could just have one equation that says this is the governing equation for the temperature in the ocean, and then you can just solve that equation, and that's a model of, it might be a very basic model, maybe it only depends on a few things. Cool, glad everyone's putting their email here. So I will add you all to Slack. And you can message me from there whenever you want, or post on the channel. And when you get onto the Slack group, make sure you add yourself to channels. And so my channel, the one about Python, is called Python Help, and you have to search for it. Yeah, so you can totally write models in Python. Most of the big ones are not written in Python, but most of the big ones are like really complicated. So yeah, I guess it depends on the definition of model. Hopefully that was helpful.
Yes, yes, yes. Thank you very much.
Oh yeah, the other thing I was going to say that you mentioned, when you make a video of like satellite data or whatever data you have, model data, it literally is just putting a bunch of images together. I mean, that's what videos are. And now there are some nicer packages out there, but even a few years ago when I wanted to animate, I also did the same. I just saved a bunch of files and then played them all together. Whereas now it's the same thing, but you have packages that will do it. And you can just say, I'd like an animation from this snapshot to this one, and it will animate it for you, which is nicer, but ultimately it's the same thing. Okay, cool. Well, it is 10:30 p.m. here. So I might call it quits and start getting ready for bed. I know it's morning for most of you probably. But yeah, please don't hesitate to get in touch. And Slack really is the best way to do it. Emails tend to get lost. I tend to, if I get a lot of emails and I don't respond right away, I usually forget. So if I send an email, or if you send me an email, I haven't responded, I will probably recommend that you try on Slack instead. It's just an easier way to organize things somehow for me. Yeah, cool.
Thank you. Good night.
Yeah, thank you all so much for joining. This is really fun. I look forward to doing this again in August and being in touch with you all in the meantime on Slack. So happy Pythoning.
Thank you.
Yep. Good to see many of you or hear all of you. Oh yeah, I didn't take a picture. Those of you still on, do you mind if I take a screenshot? You don't have to turn your video on. We can just do it. Or you're welcome to. But I like having screenshots for the website.
Picture?
Yeah, exactly, yeah.
Oh, you can go
All
ahead.
right.
Okay.
Oh, yay, I can see everyone. Yay, it's so good to see you.
Yeah.
Hey, hello.
Hello.
All right, I'm going to take the screenshot, so smile. I look a little stupid, but that's okay. Yay, it's so good to see you all. Thanks. Oh, wait, let me do it again. So we have Avia done. Okay. Wait, hold on, I didn't do it right. Okay, here we go. Awesome. Yay, thanks. Thank you all so much. I really enjoy this. This is fun. Let's do it again soon. All right.
Bye.
Bye, everyone.